Welcome to this special episode of Frequency Matters, the RF and Microwave Update series. I'm Pat Hindle, and today I'm talking with Christophe Massenet, Vice President of Engineering and Business Development at RF Industries. Welcome, Chris.
Well, thanks very much, Pat, and looking forward to it.
So today we're going to talk about an often overlooked but key part of the RF system, and that's the covering and concealment structure. So to start off, what is the importance of small concealment or coverings, and what is their main purpose?
So, when it comes to wireless networks, there are many dynamics going at play nowadays. The first one is the market. The wireless market is bringing a lot of densification to the network to cover all kinds of areas, such as dense urban areas and new frequency bands as new standards get awarded, which means that there are a lot more small cells everywhere. So that's the number that's growing up. The second aspect is nobody wants to see these things. And because once you start putting them up on light poles or everywhere in municipalities, and especially municipalities are now dictating more and more to actually hide these things, or at least conceal them. So you see some kind of a municipal appliance as opposed to a rat's nest up on the pole, if I may say. And third, technology. As you deploy these things, it's not just a thing to hide everything. It's another to also be able to maintain them easily. And even more importantly, in some cases, to not impact the RF propagation at all, so that the network coverage and capacity can still be maintained.
Yeah, complete protection, but not to interfere with any of the signals. So that's a tough assignment.
Yeah, exactly. You want the network to be totally invisible to your eyes, but still completely visible to your phone or whatever device you use to communicate.
So you've developed a new concealment material called TruField. What makes it better than other solutions that are on the market today?
So TruField is an acronym that we kind of invented and also trademarked to have the true, integrity of the signal and field, obviously, for the wireless signal propagation. The idea of this is to be RF perfect, in a way, to be totally RF transparent. And that's what we developed together with Saint-Gobain as our critical partner in this field. They have been in the concealment and fabric manufacturing forever, meaning several decades in other types of application. We partnered with them to adapt very specialty fabrics into the wireless small cell environment. So RF performance was one of the key aspects. The second one, which kind of comes with it because it's a fabric as opposed to a hard shell that you have to install over a small cell, is that it is flexible, which means the access into the equipment inside it becomes very easy, as opposed to needing a crane to lift some kind of a cap, if you will, and therefore it's easier to maintain. The other aspect, though, is because this RF performance is so good, it is also making the structure future-proof. As we know today, frequencies bands used into those networks are going higher and higher. We're now into the millimeter wave up to 40 gigahertz. And that means that when you get to even higher frequencies, which apparently are going to happen someday soon, or even from a band to another, or from a carrier to another, as they swap equipment into a given infrastructure, it makes the whole system future-proof because it is totally RF transparent from pretty much the low bands, sub 1 gigahertz, all the way to over 50 gigahertz.
Wow, that's impressive. So how does its RF transparency compare to other materials?
So, the performance we've seen in that material is that we've tested it over all these frequency bands I just mentioned with a worst case scenario of 0.2 dBs. If you're into the RF propagation world, you know that 0.2 is basically nothing, especially when you get to over, into the millimeter wave region. How does that compare with other types of material, which could be, as I said, hard shelled structure or thicker plastic material? Some can be, somewhat in the acceptable domain, around half a dB, maybe 0.6. But as we go so high in frequencies, millimeter wave especially, and you start steering beams, which is what these new millimeter wave 5G radios do as they shoot and target you sideways and up and down, you can get losses that are much higher, especially up to a dB or a dB and a half, which becomes not so acceptable anymore.
From an in-field point of view, how does it stand up to the environmental extremes, and is it easy to install?
So, as I said, the As far as installation and maintenance, because it's a fabric, it's lightweight, it's easy to carry. Imagine yourself in a bucket truck having to install some kind of a sock over a structure on top of a light pole. It's very easy with a fabric type solution because it's lightweight and it's flexible. So you can literally install it just like a sock. That's why we kind of call it a sock in terms of covering the structure, compared to hard shell solutions, which would in some extreme cases need a crane to be lifted up there and attached. It's obviously much easier. Now, in terms of weather resistance and environmental resistance, the fabric itself is extremely durable. As I said, we partnered with Saint-Gobain, who has been in this field for decades, and they've used this fabric in outdoor environment for, again, several decades, proving that the fabric structure, which a lot of it is made out of Kevlar, together with some Teflon material, is basically using extremely strong material, but also extremely durable. It's been proven that not only RF is almost perfect from an RF perspective, but it's also very impervious to anything happening in the future in the system. Not only that, but it also ensures that the RF performance are not only going to be great on day one, but also as time goes, because the Teflon, being extremely hydrophobic, is going to repel anything that would drop from the sky. It could be rain, it could be ice, it could be bird droppings. Anything will not stick to it, which ensures that the RF propagation will not be disturbed by anything that could be sticking on the structure.
Yeah, it's really important for the moisture to drip off, because that really has a high attenuation, especially at millimeter wave.
Yeah, exactly. When you get into the millimeter wave region, if you start having a material that that absorbs moisture or gets wet, even if the rain was literally sticking onto it, wetting it in a way, having a water film over it, it would be absolutely dramatic. And this Teflon material is absolutely perfect in that regard.
So what future plans do you have for this type of material now that you've developed it?
So first of all, TruField for us is not one product. It's really a platform. And by that, I mean, as you can imagine, small cell deployments in the future are going to have to change radios, going to have to change frequencies. So there will be all kinds of needs in terms of size, either in diameter or in height, or even in shape for that matter, because we started with the cylinder, which most pull-top solutions are today for those types of applications. But there are already other types of shapes, such as square or oval, or different types of shapes that will emerge as municipality start to impose guidelines on the look and feel of them, or even to fit with new upcoming type of equipment that will need to be concealed. What we really created is a structure to hold all the radio equipment, and that will be covered with the fabric sock over it. And it can be sized in all kinds of different diameters, height, and shape as well.
Well, thank you so much, Chris, for talking with me today about RF concealment and coverings. I really learned a lot about them today. And your TruField concealment material really has advantages over the current solutions. So I think it will do well in the marketplace. Thanks to our audience for listening, and join us next time on Frequency Matters.